All right, this article, the title is Soils Help to Combat and Adapt to Climate Change by Playing a Key Role in the Carbon Cycle. It's put out by the Food and Agriculture Organization of the United Nations, so that is a worldwide recognized organization. The caption on this picture, a woman crossing one of several streams which feed an irrigation canal used for climate-smart agriculture in Tanzania. So Tanzania is in Africa. All right. This article was put out in 2015 for the International Year of Soils. Healthy soil provides the largest store of terrestrial carbon. When managed sustainably, soils can play an important role in climate change mitigation by storing carbon sequestration, and decreasing greenhouse gas emissions in the atmosphere. Conversely, if soils are managed poorly or cultivated through unsustainable agricultural practices, soil carbon can be released into the atmosphere in the form of carbon dioxide, CO2, which can contribute to climate change. So, soil in itself is a solid, but this article is saying that if we are poorly cultivating our soil through unsustainable practices, that soil can be released into the atmosphere in the form of a gas. So what happens is the soil heats up, and then because of that temperature change, can then turn into the carbon releases into a gas combined with oxygen. The steady conversion of grassland and forest land to cropland and grazing lands over the past several centuries has resulted in historic losses of soil carbon worldwide. However, by restoring degraded soils and adapting soil conservation practices, there is a major potential to decrease the emission of greenhouse gases from agriculture, enhance carbon sequestration, and build resilience to climate change. So that is a pretty cool statement. Right, you can see the landscape management in Japan. Looks like rice, potentially, I'm not sure. Soils and the carbon cycle. The carbon cycle is the exchange of carbon in various forms, so carbon dioxide, which is a gas, between the atmosphere, ocean, terrestrial biosphere, and the geological deposits. Most of the carbon dioxide in the atmosphere comes from the biological reactions that take place in the soil. Carbon sequestration occurs when carbon from the atmosphere is absorbed and stored in the soil. This is an important function because the more carbon that is stored in the soil, the less carbon dioxide there will be in the atmosphere, contributing to climate change. So the carbon cycle, so you see photosynthesis. Plants use carbon dioxide from the atmosphere, water from the soil, and the sunlight to make their own food and grow in a process called photosynthesis. The carbon they absorb from the air becomes part of the plant. Okay, so there's the air, and it becomes part of the plant as food. 2, animals that feed on the plants pass the carbon compound along the food chain. So here's your animal, the consumer, and they're eating the plants. 3, most of the carbon the animals consume is converted into carbon dioxide as they breathe, respiration, and is released back into the atmosphere. So humans and animals, we breathe in oxygen and we breathe out carbon dioxide, going back into the atmosphere. When the animals and plants die, the dead organisms are eaten by decomposers in the soil, bacteria and fungus, as well as like worms and things of that nature. And the carbon in their bodies is again returned to the atmosphere as carbon dioxide. Okay? So we have this right here. We're in the ground, turning to dioxide. On some cases, the dead plants and animals are buried and turned into fossil fuels, such as coal and oil. Over millions of years, humans burn fossil fuels to create energy, which sends most of the carbon back into the atmosphere in the form of carbon dioxide. So you see how we have the fossil fuels, it turns back into, they extract it from the ground, and the fossil fuel factories, like the oil factories and things like that, they are creating more combustion that goes into the atmosphere that we need the plants to clean for us. So See, that is our cycle. Key challenges. Climate change represents a serious threat to global food security, but least because of its effects on soils. Climates in the temperature and rainfall patterns have a great impact on the organic matter and processes that place in our soils, as well as the plants and crops that grow from them. In order to meet the related challenges of global food security and climate change, agricultural and land management practices must undergo fundamental transformations. Improved agriculture and soil management practices that increase soil organic carbon, such as agroecology, organic farming, conservation agriculture, and agroforestry, bring multiple benefits. They produce fertile soils that are rich in organic matter, which is carbon, keep soil surfaces vegetated, require fewer chemical inputs, and promote crop rotations and biodiversity. These soils are also less susceptible to erosion and desertification and will maintain vital ecosystems such as the hydrological and nutrient cycles, which are essential to maintaining increasing food production. So FAO also promotes the united approach known as climate smart agriculture to develop the technical, policy, and investment condition that supports its members countries in achieving food security under climate change. The CSA practices sustainably increase productivity and resilience to climate change adaptation while reducing and removing greenhouse gases whenever possible. Mitigation. So this is now talking about what this organization is doing to put this information into action. The Organic Soils and Peatland Climate Change Mitigation Initiative. Peatlands store tremendous amounts of carbon. However, when they are drained and used mainly for agriculture, grazing, and forestry, peatlands become significant source of greenhouse gas emissions. Peatlands drainage and peat fires are responsible for almost 10% of greenhouse gases emissions from the agriculture, forestry, and other land use sector. The vital role peatlands play in avoiding and reducing greenhouse gas emissions, as well as water regulation and unique biodiversity conservation, is insignificantly recognized. The Organic Soils and Peatland Climate Change Mitigation Initiative is an informal work of organizations established to raise awareness about peatlands, promote strategic action for reducing greenhouse gas emissions from peatlands and organic soils, and safeguards their other vital ecosystem services. FAO and the initiative identify three main strategies for reducing emissions from peatlands and organic soils. 1. Secure undrained peatlands to prevent emissions. 2. Re-wet drained peatlands to reduce emissions. And 3. Adapt management strategies for peatlands that cannot be re-wetted. So, these seedlings in a tree nursery. The moringa tree can play an important role in mitigating climate change and increasing the incomes of poor farmers in Africa. Three River Sustainable Grazing Project in China. Restoring degraded grasslands through sustainable grassland management can lock more carbon in soils and biomass, increasing the water hold capacity of the soil and enhance grassland biodiversity. The Three River Sustainable Grazing Project in Qinghai province of China aims to restore degraded grazing land and sequester soil carbon, while at the same time increasing productivity, building resilience, and improving livelihoods of smallholder herder communities. The pilot program is helping local yak and sheep herding households adapt a combination of sustainable grassland management options related to grazing intensity, grass cultivation, and animal husbandry. The average annual mitigation potential in the first 10 years of the project was estimated at 63 tons of CO2 equivalent per year. So that's reducing the amount of CO2 that goes into the air each year. Climate smart agriculture and smallholder farms in Kenya and Tanzania. As part of the two pilot projects in Tanzania and Kenya, FAO's mitigation of climate change in agriculture program selected and promoted the uptake of different practices based on experts and participatory assessments with farmers. Some 9,000 farmers 9,000 farmers in both countries. Wow. 40% of whom were women received training on climate-smart agriculture, resulting in 736 energy-efficient cooking stoves being adopted to reduce deforestation. 79 tree nurseries were created, 417,000 tree seedlings were planted, and 3, I don't know what a ha, of terraces were established. That's got to be something. In 204 farms. Ha of terraces. I don't have any clue what that is. To conserve water and soil. I'll have to do some research. 2 biogas digesters were also installed to produce renewable energy from cow manure. So cow manure actually is something that transmits lots of gas, but we could potentially use that gas as renewable energy. That's some new technology that's coming out. So key facts. Land use, conversions, and drainage of organic soils for cultivation are responsible for about 10% of all greenhouse emissions. It is estimated that because of drainage, peatlands are currently the third largest emitter of greenhouse gases. It is estimated that soils can sequester about 20 pgc's, petagrams, of carbon in 25 years, more than 10% of the anthropogenic emissions. Greenhouse gas emissions from agriculture, forestry, and fisheries have nearly doubled over the past 50 years and could increase an additional 30% by 2050 without greater efforts to reduce them. Wow. Emissions generated during the application of synthetic fertilizers accounted for 14% of agricultural emissions in 2012 and are the fastest growing emission source in agriculture, having increased from some 45% in 2001. Peatlands and organic soils contain nearly 30% of the world's soil carbon, but only cover 3% of the Earth's land area. The AFOLU sector is responsible for just under a quarter of the anthropogenic greenhouse gas emissions, mainly from deforestation, the agriculture emissions from livestock, soil, and nutrient management. Soil carbon sequestration increases the ability of soils to hold soil moisture, withstand erosion, and enrich ecosystems' biodiversity, which helps cropping systems with better withstand droughts and floods. That's pretty big, especially with how our climate has been changing. So, these are some interesting ideas and content, okay? So please go ahead and reflect on what key concepts you took away from this article, either as a written document or on Flipgrid.